Welcome. The next set of notes that we're going to be discussing is what we call solving a linear system of equations. And simply put, a system of equations is a set of two or more linear equations that have the same variables. So we have at least two, so that qualifies for a linear system in the fact that we have two or more, and the fact that we also have the same variables. Now what we're going to be doing in this video is we're going to be solving this linear system by graphing. We already know how to graph, and we'll go ahead and review that. I will go ahead and create a table for this first equation, equation number 1. We have our x and our y values. I'm going to make this just a little bit bigger. And we choose our x's according to our denominator. We always know that our first x is going to be 0. Our next x is going to be whatever the denominator is, and in this case there is no denominator, so I can always use 1. And then I use the negative part of the denominator. The second part of this is we have to figure out the y values that go along with this. And to do that, we simply get ourselves a calculator. And we plug in the equation. My equation is x, and x is what I'm substituting the 0 in for, so I will put that in parentheses. I'll add 1 to it. This is x plus 1, so 0 plus 1 equals 1. In other words, when x is 0, y is 1. I will change that 0 to a 1. You can go ahead and follow along with your calculator as well. When x is 1, y is 2. And now for the third value, I'll change that 1 to a negative 1. I will go ahead and use my insert key on this, and you can use the insert key on your calculator. And it's important that you follow along on your own, so you learn how to use your calculator in doing this. Now we have a negative 1 plus 1. That will give me an answer of 0. Now we have three ordered pair. Remember, we plot the x and then the y. The x goes left to right, the y goes up and down. I have 0 and 1. So there's my first point. My second point is 1 and then up to 2. And my third point is a negative 1 and 0. Now what we want to do is to take a straight edge. We'll go ahead and draw us a line for this graph. Now we'll make another table with this value, using values for this equation. We'll make ourselves a second table. There's the x values and the y values. Again, we don't have a denominator. I will go ahead and use 1. First value is 0. The second value, like the other table, is 1. And the third value will be a negative 1. Now, just like before, I will just simply use my calculator. Where I put a variable, replace it with a number, I'm going to use parentheses. I have a negative x. My first value is 0, minus 3. We put the 0 in there. Getting a little bit carried away on the 3's. I got two parentheses in there I can't have. Let me see if I can get it out. So when x is 0, y is a negative 3. Now I'll put 1 in for 0. When x is 1, y is a negative 4. So there's 2 points. Now I have to put a negative 1 in here for x. I will use my insert key and put a negative 1 in. Nope, that's not what I need to do. Insert key. There we go. So a negative, negative 1. Now remember that negative comes because of the negative in front of the x. And this is the value that I'm putting in for x. And that value will be a negative 2. The black line is from my first equation. I will graph my second equation with a red line. So 0 and a negative 3. 0 and a negative 3 would be right there. I have 1 and a negative 4. And then I have a negative 1 and a negative 2. This is where the line goes this way. So now take your straight edge. Do not try to do this freehand. You will line up your points. You'll draw your line and make sure you draw your line all the way through your graph. Now we can find our answer. This point, or these two lines, intersect at this point right here. That point has the ordered pair, a negative 2 on the x. So x equals a negative 2. And then the y value for this point is a negative 1. So the y value is y equals a negative 1. This means that the solution for problem number 1 is the ordered pair negative 2 and a negative 1. Really what this means, if I take a negative 2, I put it in for x, and I take a negative 1 and put it in for y, the left-hand sides and the right-hand sides of both these equations will become equal. Let's take a look. So I have a negative 1 as my y. This is for equation number 1, equals a negative 2 plus 1. That stays a negative 1, and negative 2 plus 1 is a negative 1. So the left-hand side and the right-hand side are the same number. So that means that this two-ordered pair is a solution to this equation. Now let's check the second equation. Again, I will use the points negative 2 and 1. Negative 1 is the y, so I have a negative 1 equals a negative 2 minus 3. So negative 1 and negative 2 becomes a positive 2. A positive 2 minus 3 is a negative 1. So that does check out. So in short, we graph both equations. We create tables for both equations. Make sure you draw a straight line. The intersection point is the solution, and what that means to be a solution is that this ordered pair will make both equations read the same number on the left-hand and right-hand side. That's what it means to be a solution. Okay, we're going to jump over to equation number 2. We'll do equation number 2. I'm going to go ahead and erase what we've already got there. Now this is a little bit more interesting because we have different denominators. We'll go ahead and make a table for our first equation. There's the x and there's the y. I will choose 0 for my first x, 4 and a negative 4 for my second and third x, and on the second equation I will use 0, 2, and a negative 2. So 0, 2, and a negative 2, and there's my x and my y. Now let's take our calculator. We'll put this first equation in. So 7 divided by 4. We're substituting the x out and putting a number in. So I'm going to put that in parentheses to show that I've substituted in a variable. I'm going to add 4 to it. So I have 4. So when x is 0 in this first equation, y is 4. Let's change the 0 now. We'll change it to a 4. And let's see what we get. So that turns out to be an 11, so that's a very large number. We'll see what we can do with that. And then I have a negative 4. We'll change that to a negative 4 using my insert key. When x is a negative 4, the y value is a negative 3. I'm going to go ahead and plot this one. So remember, the x's go left and right, the y's go up and down. So I have 4 on the x. Oh, let me do the 0 first. 0 on the x, 4 on the y, 4 on the x, 11. So I'm going to see if I can get 11. So there's 5, 6, 7, 8, 9, 10, 11. So somewhere up there is 11. Now I have another one that's a negative 4 and a negative 3. Now I'll take out my straight edge. I'll graph these lines and let's see how close I came. I came kind of close, but at least I know I'm going in the right direction. This is the line for the first equation. Now I need to graph the second one. So the same idea. We'll take our calculator. 1 divided by 2. Put a 0 in for the x. Subtract 1. And I get a negative 1. It changes to blue. I'll change the x now to a 2. When x is 2, oops, it didn't do it, did it? When x is 2, the y is 0. And now I'll change it to a negative 2. Put my insert key and put the negative in front. Hit enter. When x is a negative 2, y is also a negative 2. We'll now graph these points. 0, negative 1. I have 2 on the x, up and down is 0 on the y, so I don't move anywhere on the y. Then I have a negative 2, negative 2. Negative 2 on the x, negative 2 on the y. I'll go ahead and graph my lines for the blue one. And you can see where the intersection point is. That intersection point is right here. Let's go ahead and pick that off. So that says right there that x is a negative 4. If I look right here with my y, y is a negative 3. This means that the solution to this linear system is x equals a negative 4 and y equals a negative 3. That is the point that lies on both of these lines, so that means it has to be a solution to both of these equations. That concludes the video for these notes, and go ahead and make sure you do these two problems, and we'll see you later.